Okay, moving on from ellipses to hyperbolas. All right, so what we know about this, and I'm actually going to graph it as we go because this information here is helpful to me as I figure out the equation if I can see it. So we see the foci are at plus and minus 3, 0. 1, 2, 3, there's one. 1, 2, 3, there's the other. Okay, so we can tell that this is a back and forth. This is an x-oriented hyperbola, which means that the x is going to be the positive term and the y will be the negative term. Now, vertex 1, 0, which would be right here. Now, I had to look this up because I thought that doesn't make any sense because the center should be between the two foci, but the vertex is not the center. The vertex is where the little branches cross. And I noticed that my foci are plus and minus 3, 0, which means that we have a center which is at 0, 0. And if I know this vertex, it will also be symmetric, and it will be on the other side as well. So, things we know. Like I said, the x term is going to be positive. I know my center is 0, so I don't have to subtract anything from the x. And it'll be divided by, and I can see I'm going out 1 in each direction. So under here I would put 1 squared, or 1. Then I can take away y squared, and again, 0, 0 is our center, so I don't have to subtract anything there. This will be what I don't know yet, and then equals 1. All right, so similarly to the ellipse, we have a relationship between the a, b, and c, okay, and it is c squared equals a squared plus b squared. Now you can notice it doesn't matter which one's a, which one's b, because it's a commutative property is an application here. All that matters is that this number is the focal distance, okay? So here our focal distance is 3, and we'll make A be the major player here, and then we'll solve for B. All right, so what we've got here is 9 equals 1 plus B squared, so B is going to be equal to the square root of 8, or 2 times the square root of 2, depends on how your teacher likes you to write it. So and then b squared is what goes under the y value here, so that will be the 8. Okay, and then our final project here is to finish plotting this. Now the vertex back and forth, that will be the edge of our frame here, and then when we're going to go up and down, we got the 2 times the square root of 2, which is about 2.8, which is about there, positive and negative. Okay, and what we do is we kind of make a frame to support our parabola, or hyperbola, sorry. Hyperbola, I can say it right. And then I was taught if you make kind of like asymptotes here through the corners of the box, that will help guide you as you graph. Okay, so the actual graph will be the vertex here, and then it'll be, my paper is going to move, it'll stretch up and approach those asymptotes as the branches get farther out. Okay. That was pretty bad. You want to stay close and really more curvy than that. I probably should have gone about like this. There we go. All right, if I wasn't using pen, I could have erased. So there's a good lesson for all of us. All right, there's your hyperbola.